I request you all to please download either the data from the chat box or from the shared drive and upload it in your Google Drive. I'm giving you some time, maybe a minute, so that you can upload it. Meanwhile, those who have either uploaded or uploading, they can create a new notebook. Please create a new notebook, a Google Collaboratory notebook, somewhere in your Google Drive. So for today's practice, the hands-on session will have a small data set, which is from this particular website.
Samir, will you please once again share the drive link? Thank you.
Yes, ma'am. Yes, ma'am.
I think I have. So this contains two different data set for anomaly detection. One is this rotary light detection, which one is working, and the second one is hazelnut crack detection. We are using this data set, hazelnut crack detection. It is a small data set, as you can see. We have shared the data with you. So kindly upload it. When you are done with the uploading process, report it in the chat box that uploading is done or uploaded, so that we can go ahead. As ma'am has said, for the in today's lab session, we will have two different approaches for implementation. One is SVM. On the same data set, we will also implement artificial neural network. And then we will see what are the results on this practice data set. First of all, I'm renaming this. After renaming, first, then you have to mount your drive. As my data is here in this place, so I will mount the drive by clicking on this files option. So I request you all to please mount your drive. You can also use the same, like if there is any network issue or you are not able to upload it, you can also use the same, the folder I am using from the shared drive. So this is the drive. I will go to this shared drive. I think it will take time. So let me make shortcut of this folder. I'm adding the shortcut to my drive. And then I will access the drive. You can see the drive is appearing here. I have added the shortcut to the root of the Google Drive or main directory of the Google Drive. I will go inside ML for CV PAB 2022. You can also do the same. Then I will go to day 4 and then lab. After that, I will right click on this lab folder and then copy the path. Then I will change the directory to this. I request you all to kindly do the same. In your case, if you don't have access to this particular folder, you can upload data folder, which we have shared with you, or upload the data.zip file, which we have shared in the chat box, anyone in the Google Drive, and then we will start the reading the data. So can we go ahead, or we have to wait? Okay, we will wait for some more time so that you can upload it. We'll wait for a minute.
Write yes if you have already done so. Please write yes on the chat box, please.
They are writing maybe directly to me.
They are writing to you. Okay, fine.
Thank you. So somebody is asking for link again. I will copy the link. If you are not able to upload the complete folder, you can upload the zip file. You have to add the path up to the folder just before where you have uploaded data. For in your case, if you have uploaded data directly to my drive, so you have to copy the path till this place. If you have uploaded zip file, suppose we have uploaded zip file. So there is one command, unzip space, you have to use data.zip, and then it will unzip. If you have uploaded data folder in your drive, then path will be till this place. You have to copy the path. Suppose your data folder is somewhere here. You have to right click on this my drive, then copy path, and then paste the path after cd command.
Poornima, are you there?
Yes, Samir?
Yes, ma'am. Yes, ma'am. She might have disconnected due to internet.
So I told her to.
Ma'am, now I'm back. I've connected with my mobile data.
Okay, fine.
Thank you. So after uploading this data folder, you have to change the current working directory to the place where you have uploaded the data folder or data.zip file. After this, if you have uploaded the zip file, you have to run this command. I have pasted unzip space data.zip. Next, we will read the data. First of all, we will read a single image from this data folder. And then we will read all the training data and test data. So when you see the data inside this data folder, you will find there are two separate folders available. One is train folder and one is this test folder. In both the folders, two folders are there. One is good, that is hazelnut with good images without any issue, and one is this crack folder which has hazelnut images. In this, hazelnut images are available. With these cracks. So our objective is to classify good and crack images of hazelnut. So let's do that. First of all, let's read a single image from any of the either from good or from cracked folder. So I'm using C2 as well as matplotlib to read and to plot to show the image on this Jupyter notebook. You have to first of all import CV2. Then you have to import matplotlib.pyplot, and then we will alias it as PLT. Inside the lab folder, you have the data. Inside the lab folder, data folder is there. So after importing CV2 and matplotlib, next we will read one of the image. So we will use CV2.imread, and then we'll go so we have zoomed as much as possible. I think now the font is visible to you all. I will go to a particular place where any of the images are available. I'm going inside data, then train, then crack, and I'm copying any of the JPG file path by right clicking on the image and then copy path, and then I will paste the path here inside imread function. Kindly do the same. Go to the place where you have the image and then copy path by right clicking on the image and then paste the path in imread function of CV2. Then I will create a temporary variable where we will store the image. As Sameer sir has explained it, that in CV2, the default color space is BGR. So we have to convert that in RGB, this image. So let's do that. IMG is equals to CV2 dot CVT color. And then we will pass the temporary variable inside CVT color. And then the color space we want. If you want to convert in gray, then you have to write BGR to gray. But we want it in RGB. So BGR to RGB. And then using PLT, we will show the image.
Dear participants, so I think there is again an issue of internet connectivity. So she might be joining within a couple of minutes. So please be patient and thanks for being there.
Poornima, are you there? Poornima?
Yes, sir. Sorry, participants, due to some internet issues, I got disconnected again.
So, okay. Internet issue at your hostel area. Okay.
So I think all of you are able to run up to these cells. You must be getting one image. We have to read the image, training images and the testing images from the original data folder, not the single image. So let's do that. For that, there are multiple options available for reading the data from the folder. So currently we are creating a custom function that will read the images as well as the category from which the image belongs, and then it will return to us. So let's create the function, define data reading function. So here we will pass the base path, and another is the image size in which we want the image. So this is the code. I will paste the code again. After that, we will create a custom function to read the training data and test data. So we are creating the function named as data reading, which will take two parameters. One is base path, that will have the path of training folder or test folder. And second is the image size, in which we want to read all the images. So as we have to read the image and the corresponding label, so we will have the image in a either array or list. So currently we are creating a list which will have input, and 1 by which will have the label or category from which the input or image belongs. After that, we will read the classes or categories present in the training or test folder. So for that, we will create a local variable categories, which will read the data, the folder names from the base path. So to read the folder names or category names, we will use os.list dir, and then we will use base path. So it will return you one list which will consist of the class name. In this case, the class names or category names are good and crack. So it will return a list with 2 elements. Please do the same. After that, 1 by 1, we will go inside each category or each folder inside training and testing and read all the images present or belongs to that particular category. We will write a loop to read all image 1 by 1 from a single category. So we will use read a single category. These for loops and function definition we have done in the day 1 exercise. So for category in categories, it will return you one item from the list. Then we will create the path till the category path. So for that, again, we will use os.path.join, which will have base path that will be joined with the single category name at a time. As the names are good and another one is crack, but we need the category as the integer value, that is either 0 or 1. Yes, we will import it later on. In later stage we will import when we will call the function. So as we have to get the category name replaced by some integer value that will represent that particular category. So we will index all the categories. Class num is equal to, we have categories in which the index number we want for this particular category. Then we will read one image at a time. For image in os.listdir, this particular path we will read the images cv2.imread, and then here we have to provide the entire part till image. So here again os.path.join, and here you have to provide the whole path till category followed by image name. Then again we have to convert the BGR to RGB. cv2.cvt color image data, and then cv2.color underscore BGR to RGB. Next is we have to resize the image in the dimensions we will provide from this parameter. So img data is equal to cv2.resize img data, and then the dimensions in which you want the image. So we will use image size cross image size. After this, we want to explain another important concept, that is data normalization. In this process, you have to normalize the data in between the range of 0 to 1. So in case of images, your data is ranging from range 0 to 255. So to normalize the image pixels, what you have to do, you have to divide all the image pixels by 255. So you can do that. Image data is equal to image data divided by 255. So in this way, you can normalize your data. Now, next is we will add your image data in X. And then your class index in Y. And then we will return X and Y. Now we will import OS and then we will call this function one by one for training data and test data. So base path for training data is data/train, and image size we are using is 224. I'll show you the code and then we will wait for some time so that you can also write the same code. So it will take some time to read the data from drive. It has read all the data from the drive. I request you all to please do the same. You have to create a function to read the data. I will wait for you to complete it. When you are done, report it. And meanwhile, I'll explain the code again. So we are creating this function data reading to read the data and for data pre-processing. So for data reading, we are creating two lists. One is X that will have image or input, then Y that is output or label. Then we are getting the list of directories in the base path that is inside the train folder or test folder that contains all the classes or categories name by inside the folder. So we will have all the class name or categories name in this particular list. Then one by one, we will go through the list. And here we are creating another path, which will have the path of base folder followed by the category name. Then here we are accessing the index of particular category. Suppose good is at index 0. So we are accessing the index of that particular category. That will be, and then the index will be representing that particular class in the Y or output variable. Then we are again getting a list of all the files or images inside the particular folder. And then one by one, we are reading the image, then converting the BGR color space to RGB color space. Then we are resizing the image in 224 cross 224. After that, we have normalized the images. So when you normalize the image, your data distribution will be in between 0 to 1. That will help you when, as your weights are, when you use any type of network or any computation, then when your image pixels or the data is in small quantity, then it will process faster and the data will be in normal distribution. Then we are appending the data in X list and Y list. Those who are getting the error that data/train is no such file or directory, please run this ls command to check whether you have data folder in the current working location or not. If you don't have data folder, then you have to again change the current working directory to the place where your data folder resides. So if you are done, can we go ahead? Kindly respond in the chat box. Can we go ahead with the further process? So I'm pasting this code. Those who are not able to get it, you have the complete code available in the shared folder. If you are getting the error folder not found or directory not found, please run this ls command. Check your data folder is there or not. If it is not there, what you can do, you can provide the complete path of this train directory. Go to the drive, go to the place where you have uploaded the data. Suppose this is the folder ML for CV, day 4, lab, sorry, day 4, then lab, inside lab we have data, then this is the folder which we want. So I will right click on this folder, then I will copy path. Then I will paste the path here. Similarly, for the test, I will again paste the path here, and in place of train, I will write test. Then also you will get the same result. So this is nothing but your path issue. And here we are passing 224. That is image size that you can change. You can also use 64, 128. Any image size can be, depends on your requirement or the availability of the data. So I think now you will not get the error. What is the error? Can you paste? CVR is nothing we are using as CVR. We have CV2. And it's IM read, IN, not IN, it's IM. Please use IM read. Please check the code. We are pasting in the chat box. If you are getting any type of error, just follow the code. It's typo error maybe you are getting. And please provide your data in quotes. Kindly check if you are writing resize, you have to provide, I think somebody is getting system error in this line, CV2.resize, it should be image data, comma, in brackets, you have to provide image size, comma, image size. You are writing only image size. So that's why you are getting the error. This you can change. If you want 64, you can read in 64 cross 60. Here we are writing 224 so that in upcoming labs also you will not get confused that why we are using 224. It's nothing specific. It can be, you can change it. So I think let's head. We have done with data reading. Our data is here in this train data and test data. So in index 0, we have X train. And at index 1, we have Y train. We will access X, that is here in this train data. So train data 0 is there, which consists of, we are just renaming and accessing it in X train. As it is a list, we have to convert it in NumPy. So first of all, let's import NumPy as NP. Then we will convert it into np.array X train. And then let's check the shape of X train. You can see it has 36 cross 224 cross 224 cross 3. So one image is of size 224 cross 224 cross 3. And in the both the folders together, there are 36 images present. Similarly, we will do with Y train to convert it in NumPy array. And then we will check the shape of Y train. So it is saying you 36. That means it is a one-dimensional array with 36 elements. Kindly do the same in your system so that we can go ahead with the SVM creation or calling the SVM, then training the SVM and prediction. So as the SVM takes the input in 2 dimension or less than 2 dimension data, but our input data is in 4 dimension, you can see 36 cross 224 cross 224 cross 3. We have to reshape the data in 2 dimension. Kusum ma'am, you are getting the error. Please provide the path in quotes. Please provide the path either in single quote or double quotes. So let's reshape. Is it okay if you show 18? If you are getting 18, please check your data folder. You must not have uploaded both the folders inside the data, or you are not providing the correct path. You have to provide the path till train or test. It should be 36. If you are not getting 36, that means your data has been not uploaded properly, or there is some issue. If no number is coming, that means you are not able to read the data properly. It should be something like this. Please check it. Sometimes what you people do, maybe the reason is that you have separately written this import numpy, and then you have created another cell with this, and you have run this cell 2 times. That is causing the issue. So I request you all, don't create a new cell for each line. Otherwise, you may get some error. I request you to kindly get if you are not getting the result similar to this, what you can do, please write all the cells together and then rerun the code from here. Import OS and then these two. If you run the cell 2 times, maybe you will get error. This will return you X train and Y train. If you are getting 18 cross 2, 24 cross 2, 24 cross 3, then also there are chances that inside your data folder, you don't have both the folder. Either you have good folder or crack. Because in a single folder there are 18 images. It should be 36 cross 224 cross 224 cross 3. Check, go to your drive, check whether both the folders have been uploaded properly or not. So a single image is of size 224 cross 224 cross 3. So 3 represents RGB color space. These 36 represent that you have 36 images. One image of size this, and such 36 images are there. So that's why your array is of size 36 cross 224 cross 224 cross 3. For a single image, one label or one class is present. So for 36 images, you have 36 labels. So that's why in Y train, you are getting the results as 36. So I think let's go ahead with the SVM calling and then training. So before that, what we have to do, you can see that our data is, if you are getting 36 cross 800 cross 800 cross 3, that means here in place of 224, you have given 800 as image size. So that is not an issue. You can change the image size. Let's call the SVM. So in sklearn, all the classifiers are available. You can use those classifiers. So from sklearn.svm, we have to import SVC, that is support vector classifier. Then we will call this support vector classifier function. It takes multiple parameters as input. We have to provide the kernel. First of all, the very first argument, it will take kernel. So that also the kernel we are using is linear kernel for SVM classification. So you can see it is suggesting what is the kernel you want to use, what is the degree, gamma value, coefficient, shrinking probabilities. So it depends on the SVM you are creating, which type of SVM you are currently working with. So according to that, you can change the parameters. And then we will use the gamma value. as auto, not the other one. And then we will create the local variable as SVC. So it will call the SVM classifier, and the classifier is here in this particular variable. So SVM classifier takes the data in 2 dimensions or less than or equal to 2 dimensions. We have to convert our X trained data in 2 dimensions. So I'm doing the same by reshaping. X trained dot reshape. What we can do, we can convert the image, each image in 1 dimension. So X trained dot shape 0 will be as it is in the first dimension or 0th dimension. In the next dimension, what we will do, we will multiply all the shapes. So X trained dot shape, so it will convert into 1 dimension. Shape 1 multiply by X trained dot shape 2 multiply by X trained dot shape 3. Next, when you check X trained dot shape, it should be 36 cross multiplication of 224 cross 224 cross 3. So you can see this is the result we are getting. The spelling is incorrect. The kernel spelling is KERNEL, not AL. So kindly update it. Let's train the SVM classifier. So we have created the classifier in this variable SVC. SVC dot, for training, there is a function fit, which will take data, which is X train and Y train. So and then Y train you have to provide here, and then run it. As your data is small, so it will not take a lot of time. I'm waiting for you all to do the same, then we will go ahead. So you can change the kernel linear, it can be linear, polynomial, or radial basis function based. So after training, maybe most of you are getting the training is done. Tuple index out of bound, X train dot shape 132. If you are getting the result like this, 36 cross 224 cross 224 cross 3, then only you can reshape. So if you are getting any type of error like tuple index out of bound, please check first of all what is the shape of X train. In my case, now it will give me 36 cross 1502. If it is 4 dimension, then only you can reshape it into 2 dimensions. If you will run the code 2 times, then also you will get the error tuple index out of bound. So now let's do the prediction. Okay, so you have already run the same code. This time again you are running, that's why you are getting the error. Let's predict on the test data set. SVC dot predict on X underscore test data, and this will be our Y prediction. Okay. Similarly, we have done with train data. We have to do with the test data. We have to first create the data from test data 0. This will be a text X test. You must be, you can access the data from test underscore data index 0 as X test. When you check the shape, you will get it as 14 cross 224 cross 224 cross 3. You have to again reshape this X test same as X train. X test dot reshape is X test 0, 1 multiply by 2 and 3. So what we are doing, our actual data is in 4 dimensions. So we are reshaping the complete array and converting each image in 1 dimension by multiplying these dimensions. So this is index 0, that is 14. It will be same, comma. We will multiply dimension of these 3, that is 224 cross 224 cross 3. So X test dot shape 1, that is 224 cross 224 cross 3. Either you can directly write here 224 multiply by 224 multiply by 3. So your array dimension will change. I have done that already. So to rerun. Similarly, we will access Y test from test data 1. We will convert it to NumPy array. So 14 size vector is there. We have the prediction and the actual Y test both together. So let's check what is the accuracy we are getting for SVM. So to check the accuracy, we have to access sklearn matrix. From sklearn.matrix, we have to import accuracy score. And then we will call the accuracy score. It will take your actual predicted Y and actual Y as parameter, and then it will tell you what is the accuracy. So it is saying that the accuracy is 35.71. We will I think all of you are able to run till this part. So if you are able to do till this part, can you? Yes, your accuracy can be different. Yes, it could also be 64.28. .28 something, 28 2857 you may be getting. So I think all of you are able to do up to this part. This is the way we can use SVM classifier on image data set. Anyone who is not able to do till this part, or do you have any issue, you can ask. Then we will go to the other part, that is ANN classification.
We can give a small break here.
Yes,
Let the
ma'am.
participants ask you questions, and then you can start. So there are certain raised hands. Poornima, I hope you can ask them.
Yes, ma'am.
Pankaj, Amit, these people.
Pankaj sir, you can ask first.
Hello,
Yes, sir.
ma'am. Actually, what we did here in this example, basically we collected some data, like some different kind of images we have, and those are classified in two different categories.
Yes,
and
sir.
finally SVM predict on the basis of those data that what is the actual result set on our test data, right, ma'am?
Yes, sir.
So we basically. My question is basically we are using all three RGB values in the same. If we try the same with one single channel, so like is it necessary to proceed with the all three channels to for the computation of data?
No, sir. While reading, you can convert it either in grayscale, or you can use only single channel. You can skip the other two, maybe a G or B channel. It depends on your application.
Okay, so it means at some places or at some cases, one channel is response is quite good, and in some another example, like all channel are necessary to get a proper result. Is it?
Sir, I think it's application dependent. We cannot say like generally it could be possible, but it is depends on that your data.
Okay, and like as you said that SVM is taking data in just 2 dimension, like, so why we are making data in 2 dimension? That here I'm little bit confused on this place, like,
sir,
why?
in the theory lecture, you must have seen that how SVM works. So as per the structure of SVM, it takes the data in 2 dimensions only.
Okay, got it.
Process your like multi-dimension data, because each and every algorithm has its input different.
Okay, no problem. I will read that again. Yeah, I will read that again to just clarify the doubt. No problem. Thank you so much.
Thank you. So Amit sir, you can ask.
Yes, ma'am. Now here we have done the prediction of cracks, right? Now my question is, suppose if I need to after classification, suppose if I need to understand what is the size of crack, what is the length of the crack, and then what is the angle. So what option we can use?
So sir, as per my, I think as per my suggestion, you have to first of all label your data.
Yeah.
Because if you are working with supervised learning algorithms, first of all, data, you have whatever you want to predict, first of all, you have to tell the algorithm that this is the pattern or this is the thing I want to identify in the image.
Yes, ma'am.
For example, here, if you want to predict the crack location, so either you have to provide the X and Y location from where the crack is starting and ending.
Yes.
Or angle, but you have to separately provide, maybe in CSV file or any other data format.
You kahe se phenke ho?
No, but ma'am, if it is not provided as part of data set, so with after prediction, can we able to do that?
Sir, if you will not provide it, it is not possible in supervised learning. Then you have to try with like unsupervised algorithms. There are multiple restrictions. But if you will not tell what you want to predict, then maybe your algorithm will not work.
Okay.
So basically, then in that case, it will be doing clustering by looking at the patterns, looking at the characteristics of the data. It will be finding out similarity and dissimilarity between 2 different samples, And it will identify. These are the unsupervised learning algorithms,
Yeah.
what they do. So if the data labels are not given, and you are working on some problem which requires prediction into classes, then you will have to do data labeling. That is important.
Yes,
and that
ma'am.
has to be done through some expert.
Yeah, so members, that's correct. So I'm not talking about the supervised learning. I'm just talking, yeah, we do have, suppose, data set where we have labeled it, right? Whether there is a crack or not. Not extension to that problem, I also need to find out if there is a crack, right, on my test data. So what is the size of that crack and what is the angle of that crack? So
Yeah,
to solve that problem,
that is localization of the data, localization of the whatever it's anomaly or something.
yes.
That comes under object detection. We will be covering that part in a later session. But what is the size and the angle?
Yeah.
So location will perhaps help you determine the size. Angle, for that you will have to label the data in such a way that the angles can be learned.
Got it, ma'am.
I hope I have answered your question. Yeah.
Yes, ma'am. Thank you.
Surendra, sir, you can unmute yourself.
Robi Surendram, yeah.
Robi Surendran. Yes.
Good evening, ma'am. Am I audible?
Yes, sir.
Ma'am, here we are forcefully having the two training set and the test sets are in two different parts. Is it not possible that we have one data set and the application automatically splits into a training sets and the test set?
That also is possible, sir. We will do that.
Because here when we do our model, we are constraining the model rather than if you split it.
Yes, sir. So if you have like single data, that also you can split.
Okay.
Suppose
Okay.
I don't have this text test, so in sklearn itself, or you can manually or write 4 to 5 lines code, you can split the data into parts.
Yeah. Thank you, ma'am. Okay.
Hello.
So I think there is no
you
other
can
doubt.
go ahead with the rest of the session. Thank you.
So many of you are asking what we are doing this code. Can you explain the code again and how to mount the drive?
One more thing, Poornima. Somebody has written, let me just go back to, somebody has written that it will be good if you write the comment, you comment also in this.
Yes, ma'am. So maybe, ma'am, at the end, I'll comment the complete code is
like
already
we used
provided.
to do, like, yeah, we used to do in our tutorial session. I hope we write tutorial in that form. So
We
you
have
when you
shared,
come, yeah. Okay, fine.
Ma'am, we have shared.
You have shared already?
Yes, ma'am.
So that means that is there already, right?
Yes, ma'am.
So those comments are there. Okay, great.
Yes,
thank you.
Thank you. So let's create a new notebook. There we will do the same process, but with artificial neural network.
So why, Poornima, why are we doing a new notebook? Can't we do it on the same notebook?
Ma'am, we can do, no issues, ma'am. We can do here.
No, I'm asking this because your data is the same or different data?
Ma'am, it is same. The process is same. I'm just doing it so that we can maintain consistency, nothing else. So I'll do it in the same notebook, ma'am.
No, just I want to say this. Why? Because that part you will be saving.
Yes, ma'am.
Otherwise, you will have to start from the beginning.
Yes,
yeah.
Okay. Thank you, ma'am. So I will first of all make a comment here. So from here, we are starting the ANN part. what we have to access is our data that we will access from these train data and test data variable. I'm not accessing x_train and y_train because here we have already reshaped. We will do that also because in ANN we have to reshape. But first of all, let's create the model. The pre-processing part we have already done, the reading and everything else we have done. So let's create the model, and then we will understand how we can create artificial neural network or multi-layer neural network, and then we will check how it is calculating the number of parameters and output shape, and then we will train the model at the end. So I'm skipping pre-processing or data reading part. We are directly going ahead with the model building part. So for NN building, either you can use TensorFlow or PyTorch. So currently we are using this example with TensorFlow. If time permits, we will also do the same with PyTorch. So to access TensorFlow, we will inside TensorFlow we are going to use Keras. So from TensorFlow, we will import Keras. And then we will create a new model, that is ANN model we are creating. That this is a local variable where we will store the model. From Keras, in Keras there are two types of models available. One is sequential model and one is functional API model. Sequential models takes input in the form of, it can take only single input and generate single output. And here you can process the data in sequential format. If you want to create a model with multiple input or multiple output, then you can go ahead with the functional API example. So currently we are using sequential model. Functional API also we will do, maybe in upcoming labs. So from Keras, there is models available here. From here, if you want to use sequential, you have to write sequential. If you want to use functional, you have to write model. So sequential. So it will call the sequential model. Then to add the layers in the model, there is a function that is add, which will help you to add multiple layers in the model. So there are multiple ways to creating the model in TensorFlow or Keras. If you find that this is the other ways other than this way, so that is also correct. In this lab, we will follow this particular way to creating the model. In upcoming labs, we will change the syntax so that you will learn how are the ways to create the model. So ANN_model.add. This is the way you will add the layers. One of the way. So as explained by Sir, in artificial neural networks, the first layer is input layer. Then it is followed by single or multiple hidden layers. And then at the end, you will have output layer. So we are creating the first hidden layer. That also using the same Keras dot layers dot dense. So dense is the type of layer which creates, which is helpful to develop artificial neural network. So why dense? Dense is densely connected neural network because all the neurons of the first layer is connected to the all the neurons of the upcoming layer. So that's why dense is the layer. So as you can see, it is giving the suggestion. Dense takes multiple parameters as input. You can see the units or number of neurons, the activation function you want to use, whether you want to use bias or not. By default, it is true. You can see it is showing here. The kernel initializer. So somebody was asking in the first session that how you can initialize the weights. So this is the parameter you can pass. Kernel underscore initializer is equal to, this is Glorot uniform. You can use normal or the random normal distribution of the weights. So there are multiple options available in the Keras websites to initialize the kernel or weights. You can use those weight initializers. Then bias initializer. In many of the applications, I've seen that the biases are initialized with zeros, and then you can, there are other ways also. Then the regularizer you have understood in the first session, that also you can initialize from here, L1, L2, or similarly with the bias regularizer. And other options are there that generally we don't set. So let's go ahead. Now the next thing is the number of units in the first hidden layer. That is a hyperparameter, because user have to set how many parameters will be there. Here we generally follow the rule that it should be in power of 2, and it is 2n+1 way. So it also depends on your application, as well as you have to try with multiple combination that which works best in your application. So in the first hidden layer, I'm using 16 units or neurons. I'm taking it small so that I can explain you how to calculate number of parameters and output shape. Next is you have to pass the input shape to the first hidden layer, only to the first hidden layer. So the parameter is input shape we have to pass. So let me check what is the shape. When you have reshaped, you know, this is 36 cross this number 150528. So 36 images are there. That means one sample is of size 150528. So the number of neurons in input will be 150528. 150,000 and 5,200 neurons will be there. I'm writing comma here because it is one-dimensional shape, so I have to write comma. Then you can initialize the kernel or weights by using kernel initializer function. Then let's set the default one is Glorot. So we are using normal, so random, normal, and the other one is he distribution, that sir was explaining, that also we can use. Then bias initializer. So let's initialize it with 0. Then so this is your first hidden layer. Again, we will add one more layer. With 32 neurons, and we will use the same initializer. And here, no need to use the input shape parameter because we have already given the shape for input layer in the first hidden layer. So only kernel initializer and bias initializers we will use here. And now let's create the output layer for now. Later on, we will change the structure. But for now, let's create a neural network with 2 hidden layers. One is with 16 neuron and one is with 32 neurons. So model.add layers.layers.ends. We have 2 classes. One is good and one is crack. So good is represented by 0 and crack is represented by 1 when we have pre-processed the data. So we will use 2 neurons in the output layer. If you have 10 classes, you have to use 10 neurons in the output layer. If you have 100 classes, accordingly, you have to change the number of units or number of neurons in the output layer. Then in the output layer, you have to give the activation function as well. You have to give activation function in the hidden layers also. That we will do while fine-tuning the network. We will update the number of neurons and activation function. So in the output layer, you can use sigmoid or softmax. Both are different activation functions. The sigmoid gives you the output in between 0 to 1 for each the neuron, and in softmax it will give you the probability value that will be also be in between 0 to 1. But here the softmax generally we use for classification, only for classification purpose. So I think that's all. Let's now run it. And now we will take the summary of the model. So this is the summary. We will know how it is printing, but I request you all to kindly do the same in your system. We will wait for 2 minutes so that you can run the same code. If you are getting any type of error or any issue, please report it in the chat box. This is the most important part of the ANN model.
So Saida is asking, Saida Shira Moen is asking, since we have just 2 classes binary classification, why can't we use just 1 neuron in the output layer?
That also we can do. We can use 1, and here we can change the like activation function. Both is possible, but it's a like it's not. We can say that we are working with single class. We are working with 2 classes, so that we are following this standard, not using the 1 class in the output layer. So, what shape depends on, let me explain you again. What is the shape of your single sample? Suppose your data has a single image of size 10 cross 10, then your input shape will be 100. If your image is of size 10 cross 10 cross 3, that is RGB image, then your input shape will be over here. Input shape is the shape of single sample or single input, single image. In case, if you, in this example, we have image of size 224 cross 224 cross 3. That's why input shape is this 150528, because artificial neural network takes your input in 1 dimension. So each image will be converted into one-dimensional image. So can you please paste your error, whatever error you are getting, if you will paste, then it will be easier. Yes, we can use one, here you can use one neuron, and here you can use the activation function in place of softmax. You can use sigmoid and convert it in a binary classification. That is also possible. Both the ways you will, your neural network will be work well. And I request you all to please write the complete code in a single cell. If you will create multiple cells, then there are chances that you will encounter this error. Input shape is not accessible in all the layers, and then you may have more than 2 hidden layers in your network. So this kernel initializer or bias initializer initialize the weights and biases with a particular distribution, any type of distribution, in place of randomly allocating the weights. Because somebody was asking in the first session that how we can initialize the weights fixed or particular numbers in place of randomly initializing. So here in place of random normal, you can also give the fixed values or any other type of distribution. So if you are done, please report it so that we can go ahead. So you can use softmax for multi-class classification. Sigmoid also you can use here. So these are hyperparameters, 16, 32, and 2. These are hyperparameters because these depends on the developer or whosoever is developing these neural network. So ReLU activation function generally we use in hidden layers, not in the output layer. We use ReLU activation function in the hidden layers. Let me explain this model, and then we will go ahead and whatever queries you will have, we will one by one answer. So the input is this 150 cross 150528 neurons. In the first hidden layer, you have 16 neurons. So here
when you visualize, let me try to annotate. So this, suppose this is your input layer, suppose, which will have some, sorry for my writing, suppose it will have some 10 neurons in it. And this is your first hidden layer, which have 16 neurons, which we have taken currently. Then all the neurons of your input, all the input neurons will be connected to first hidden layer, like in this manner, that is densely connected. Then in the second hidden layer, we have 32 neurons. In the same way, your neurons will be connected from first hidden layer to second hidden layer. And in the output layer, you may have one neuron or multiple neurons. So in this case, I have selected 2 neurons. So here you will see the connection will be, each neuron is connected here with 16 neurons. So we have 10 neurons in the first hidden layer, and here we have 16 neurons. So number of, or your weight matrix will be of size 10 cross 16 for the first hidden layer. And number of biases here will be 16. For each neuron, you will have a single bias. Similarly, when you talk about second hidden layer, here, each neuron of first hidden layer will be connected to all the neurons of second hidden layer. So here the weight matrix will be of size 16 cross 32. And for each neuron, you will have a bias. So total number of biases will be 32. Here also, each neuron of second hidden layer will be connected to all the neurons of output layer. So the weight matrix will be of size 32 cross 2. And each neuron will have one bias. So there will be 2 biases in the output layer. So in the entire network, the number of parameters represents the size of weight matrix for size of weight matrix in each hidden layer, sum up with number of biases in all the hidden layers. So here the weight matrix will be of size 10 cross 16. Number of biases will be 16, so plus 10. Then 16 cross 32 plus 32. 32 cross 2, that plus 2 will be the number of parameters here. So here in this example, in the first dense, the number of the size of weight matrix will be 150528 cross 16 plus 16. So this much of the number of parameters will be there in the first hidden layer. In the second hidden layer, we have 32 neurons. So the weight matrix will be size 16 cross 32. 16 cross 32 plus 32 will be the number of parameters here. That is 544. 16 cross 32 plus 32. In the output layer, 32 cross 2 plus 2. That is 64. Parameters will be there. Trainable parameters will be there in the model. This is the way you will calculate the number of parameters in your model. And these are the parameters, weights and biases that will get learned in your backpropagation process. So let's go ahead with model training.
before training, you have to set some more hyperparameters. That is the optimizer you will use, the learning rate in the optimizer, what is the loss function you are using, and the matrix you are going to use to evaluate the performance. So let's use both. First of all, let's use SGD optimizer and then we will change it. So to access the optimizer, in the Keras itself, we have all the optimizers available. Keras.optimizers.sgd, and here we will set the learning rate. So learning rate generally we set in between 0.0001 to 0.1 and or 0.0005 to 0.5. So it is again hyper parameter. So you have to try with different learning rate. When you plot the training graph, then you will understand whether the learning rate should be changed or not. So here we are setting it as 0.0001. This is the optimizer we are going to use. Next, we have to pass this optimizer to your ANN model. That we will do using compile function that will compile your model with the optimizer, loss function, and the matrix you are using, accuracy, precision, recall, other things. So optimizer, we will pass. You can see the default one is RMS prop. We will use our optimizer, that is optim. The loss function you want to use. So the loss function is cross entropy loss we will use. Here, your data is in the format that is 0 or 1. So we have to use sparse categorical cross entropy loss. And we are using softmix here. Or categorical. And then we will use matrix. The matrix you can use accuracy, precision, recall, whatever you want. So currently we are using, I'm writing sparse here because I'm not converting the, what we can say, the output vector into one hot encoding. That also we have to explain that what is one hot encoding. So that maybe in the tomorrow's lab we will explain. So that's all for compilation. Optim is not defined. It is here. Okay, there is some syntax above O, so that is causing the error. After that, for training, we have fit function. So ANN model dot fit. Here you have to pass a train. And Y train. Other than these two parameters, we have to pass number of epochs. Let's set it as 30. And then the batch size, how much images you want to process at once. So we are setting batch size as 4 currently. And let's store the output of this fit function in a local variable history. So you can see the performance is changing. So I request you all to kindly do the same. When you are done till the training part, please report so that we can proceed further.
So, Neha ma'am, kindly check. I think X is in capital, so maybe it is because of that you are getting error.
Next is the prediction part.
If you are getting the error is non-time object is not called. Because all other things are correct in your case, maybe your session has expired. So ANN model, you have to rerun the code from here.
Next is identifying the matrix on unknown or test data set. So for that, two separate functions are there. For matrix identification, we have evaluate function, and on predicting on unknown data set, we have predict function. So one by one, we will see. To get the performance on test data set, we have ANN model. First of all, call the model, then dot evaluate. And here you have to pass x underscore test, comma y underscore test, and run it. So you can see the loss is 0.73 and accuracy is 50%. In your case, it can be different. So this is on unknown data or test data set. To predict on unknown data set where we don't have labels or this Y test, you have to call predict function. Here 0.5 means this is this one accuracy, it is printing it as 0.5. So you have to use ANN model dot predict to predict on unknown data set where you don't have label. So now again, if you want to use the same matrix to calculate, let's print y predict. Here you can see 0.43 and 0.5. So it is giving the probabilities for different like probability for each image. The probability of being in class 0 is 0.43 and here it is 0.56. So what you have to do, you have to use argmax. So y predict is y predict dot argmax. Sorry, we have to use numpy np dot argmax over y predict, and axis we will set as 1. So it will give us the maximum of. So you can see this is the prediction it is giving us. And the actual one we have in Y test. So this is the way it is predicting. Your model is trained for, and it is giving 50%. That means 50% it is incorrectly classifying. So this can be because of less number of data, it is not trained properly.
So what is, can you compare the performance of two
Yes,
classifiers?
so ma'am, many of them is getting this 64.28. In my case, I'm getting 35.71, and here I'm getting 50%. So maybe they are getting here also, they can get 60s and 72 up to 72. I have.
No, by this I mean,
Like we have to change here the nuance.
Scroll down, scroll up. Okay. So is that all? I think it's already 7:52.
Yes, ma'am. So if anyone has.
So we can ask participants to, like Darshan has raised his
Yes.
hand. Darshan, can you?
Hello, madam. I'm audible, madam.
Yes, sir.
Sir, madam, that the parameter value is reduced now, madam, from huge number to from 66.
Pardon, sir.
There
Parameter
any-
values.
There, madam, in the NN model, madam, little bit upwards, little bit higher, here, down, madam. In the summary, madam, NN model
Okay.
dot summary. So here parameter is just 240, some number is there. Finally, it has gone to 66 in the third column.
Third column 66. No, okay, sir. Yes, yes.
Is there any formula, madam, to how to calculate the trainable parameters?
Yes, sir. That formula is number of neurons in the first layer multiply by number of neurons in the next layer. For example, this 66 we are getting because your output layer has 2 neurons and it is connected with the previous layer is with 32 neurons. So number of parameters will be 32 cross 2. That is your weight matrix size. 32 cross 2, that is 64. Your weight matrix will be of size 32 cross 2. And for each neuron here, you will have one bias. So 2 biases will be here. So that's why we are getting 66.
Okay.
Similarly, here also 16 cross 32 will be weight matrix. And for each neuron, one bias. So total 32 bias. 16 cross 32 plus 2. Same with first. 150528 multiply by 16 plus 16.
Thank you so much, madam.
Thank you, sir.
So Pankaj Kumar, you please ask your question.
Hello, ma'am. Hello.
Yeah.
Yeah, okay. Ma'am, I have two questions. First is related to this number of layers and number of neurons we are selecting in this case. So if we change the number of layers, like we can increase, we can add on more layers, or we can add more neurons on a single layer and can reduce one layer. So like how it impact the process? Will it impact directly to the result? Our model will performance will increase or decrease, or it will impact on the timeline, like how long this process execute to get the result. Like first question is this, ma'am.
So can I answer this question,
Yes,
Poornima?
yes, yes, ma'am.
See, the deeper is the network, the more abstraction it learns from the data, right?
Okay.
So if the data is not very, like if your data is having, your data characteristic is, the data features are such that they're not very complicated, not very difficult. from the point of view of understanding its features, then less number of layers would do. If you want to get the work done from just one single layer, there are some machines which are known as extreme learning machines. They use only one layer.
Okay.
Now they are doing also very well in many cases, but deeper is the network, higher is the probability that it will learn the characteristics of the data in a more abstract way. So once we say that it is an abstraction, it learns in abstraction, it basically is able to generalize well. That's the idea. So generalize well is what precisely is expected from a learning model.
Okay,
Now,
ma'am.
yeah, so, but if you have more neurons, some of them will be learning redundantly. They will be learning the same features or extracting same features, and there can be some redundancies. But it is always preferable to have redundancies than to lose the information. And therefore, people choose a lot of neurons in each layer.
Okay, ma'am. So like while choosing the number of neurons, like how do we decide? We just see the like
it's hyperparameters are generally tuned. They are first by trial and error, by previous knowledge. You do that, and then by trial and error they are tuned. There's no hard and fast rule, but as Dr. Partha Pratyam said, that there are certain theoretical results which say, for example, if the input data feature is having size of say 4 or 40, then you can take the number of neurons to be 80 plus 1, like 2n plus 1. For a data sample with having n features, 2n plus 1 number of neurons in the first hidden layer can do very well. But again, these are theoretical results which have been further improved. But in practical cases, it's difficult to.
Okay, ma'am. Thank you so much. Ma'am, can you just scroll down to the bottom side? I have a question. Okay, the question is, ma'am, on the ANN at the end, like.
Okay, we are at the end only.
Yes, ma'am. Okay, so here are two statements. One is the evaluation and second is the prediction. So what I understood from these two different statements, the evaluation is just a kind of summary and the prediction is actually for producing the result. Is it correct, or like why we like executing two different lines to get the output?
So here you can see that we have the labels with us. We have the output in which class or category your data belongs.
Okay.
But when your model is ready completely,
okay,
you have to test it on real-time data where you don't know from which category the data belongs.
Okay.
In that case, for real-time prediction, you use this predict function where you don't have the label.
Okay, so
Both
okay here, okay, both are different.
Yes.
Okay,
yeah,
ma'am.
so your model is ready. Basically, your model is evaluation is the performance evaluation of your algorithm. And testing means you are testing for an unknown sample. Okay. Shall we move to the next person? Shyam Bahadur, I'm asking Shyam Bahadurji, I'm asking you to unmute.
Okay, good evening, ma'am.
Yeah, good evening.
Hello. Yes, ma'am. My question is, if we increase the number of epochs, will the accuracy of the system will increase?
Number of neurons, what did he say?
No, number of epochs.
Epochs. The number of epochs, basically, say, you suppose you have a child, right? The child is very bright. If you tell him 3 examples, the 4th example he will learn automatically. I'm talking about mathematics, right? The child is not good in mathematics. He may be very bright in other areas, but not good in mathematics. Give him 15 examples. He will learn slow, and his performance may not improve with that, even with 15 examples. So similarly, machine learning algorithms are also like that, that the number of epochs, after certain number of epochs, they may not learn further because they have already exhausted from the data set. They have learned whatever they could learn. Beyond that, what happens that the error tends to it may start increasing also. Have I answered your question? So I go to the next person, Pranamita Nanda. Yeah.
Yes, ma'am. Good evening, ma'am.
Good evening.
Ma'am, my doubt is for whether for the same hyperparameters, is it possible to get different accuracies? If so, why?
Because your weights actually are randomized, like initial, you do not know what is the starting point, right? The moment you randomize your weight, the starting point can be very close to a global minimum. It can be very far from a global minimum or a local minimum even. So the accuracies may change. The performance may not be the same. May not be the same always.
Okay.
Is that clear?
Okay, ma'am. Then how to know? Just one more. If suppose one time I am getting suppose 50%, next time I am getting 70%, then how do I know for what? That means whether I have to change the hyperparameters, or is it because of weight it is?
So you slowly have to change the hyperparameter. Then only like take one hyperparameter, slowly change its values, and then you understand. Like it's a problem of research in itself. So there's no hard and fast rule, as we said.
Okay, ma'am. Thank you.
Thank you. So I'm requesting Manojit to please mute his. Is Manojit available? No, I don't think he was present. All right, Femina, request you to please unmute yourself.
Thank you. Thank you, ma'am. This as we increase the hidden layers, will we get more accuracy? I mean, how do I balance that? Deciding the hidden layers?
As I just told, that hidden layers help you learn the data abstraction features at different abstraction level, right? So it depends on the data. It depends on the application from where the data is coming. Then the more hidden layers. And the second thing is that the deeper is the network, it requires more data to train itself. If you have a small number of data, if you have only 200, 300 samples, then 2-3 hidden layers are sufficient. If you have some, say 5,000, 10,000 samples, you can take up to 7, 8, 10 layers. Some people even take up to 50 layers. So we'll be talking more about that in a transfer learning session later. Okay, thank you. So now I request Manojit, please, unmute yourself.
Good evening, ma'am.
Good evening.
Ma'am, actually, I have one question that I have a image feature like 1 lakh image feature. Can I directly apply this image feature in this ENN?
You have an image feature, if your sample is of size 1 lakh, then definitely neural networks are known as feature extractors. You can apply. Your neural network will be very large. And what kind of feature is this? By the way, it's a temporal data or it's a spatial data? Is it a temporal data or a spatial data?
Ma'am, it is a spatial data. If
If it is a spatial data, then you will learn tomorrow. My colleague, Dr. Professor Preeti Khanna is going to deliver a lecture on convolutional neural network in place of me because of some exigency. I'm not taking. She will be taking the lecture. So you will learn more about temporal data, spatial data tomorrow.
Okay, ma'am. Is there any transfer learning concept we are going to use in our coming session? But I want to know that shall we use this transfer learning feature?
Unless you learn what is CNN, transfer learning will not be of any use. So we will be doing transfer learning in a later session. First, you will learn CNN and then transfer learning also.
Yes, ma'am. Thank you, ma'am.
Saidaji, request you to please unmute yourself.
Yes, thank you, ma'am. Good evening. Am I audible?
Yes.
Yes, ma'am. Ma'am, actually, I was wondering the NN model that Poornima ma'am designed in this session, she didn't specify the activation functions for the hidden layers. So I was wondering without having an activation function, those hidden layers won't be just computing some linear function based on the weights and biases. So would that be meaningful? I mean, activation functions help in introducing that non-linearity thing and learning the complex
Poornima?
features.
Yeah. Poornima, are you there?
Yes, ma'am.
Yeah.
Yes,
have you
shall
not
I
taken
repeat?
any activation function?
No, ma'am. Initially, I have not taken. I want to one by one want to add the parameters in the function.
Yeah.
Okay, so you
So
would be adding
basically, if you don't take any activation function, it will be a linear, like affine approximation. But if you take an activation function at the end, it will introduce non-linearity at the end only. So this was just to help you understand how things are growing, but you can take activation function for sure. I mean, generally, it's a practice that activation functions are taken. Okay. Thank you. Next is some Vaishali, and somebody raised hand. I don't know, Vaishali. I don't know if she was the person who raised. Vaishali, are you there? Vaishali, ma'am, you were asking some question? All right, so there are no further questions, and we wish you a very good evening. Thank you so much, all the participants, for your active participation.